Hi there, my name is Cherise and I am a children's librarian at the Tacoma Public Library. And today I have 3 activities having to do with water. So we're going to explore some of the scientific properties of water today. Our first activity will be a float tank. So we are going to be testing household objects, things you can find around the home easily. We're going to be testing them to see if they float or sink. So we'll be looking at water density for that activity. Our second activity will be doing a little fun thing to make raisins swim around in liquid. And our third and final activity will be making shaving cream clouds to imitate and kind of illustrate how rain falls from clouds. So for our first activity, I made a float tank. And I took this is actually a plastic salad bowl, and I filled it with cold tap water. You can use any kind of preferably clear container that you have around your house. So Tupperware container, a storage container, even a kind of a large cup or plastic recyclable container is fine too. So I'm going to put this in the camera so you can kind of see. And I have different objects around the house that we're going to test to see if they float or sink. So I have a little tray of goodies here with different things. So here is a leftover Easter egg that I made maracas with in my last video. I'm just going to test that. Pencil, erasers, some pennies, some dried green split peas. You can use different types of beans and seeds as well. I don't really have any besides those around the house, but just use whatever you've got. A little votive candle and some raisins. I also have some food items. So I have a hard-boiled egg that I've labeled with an H so I can remember, and a raw egg. I have some red grapes and a mandarin. Okay. So with our float tank, we're going to be exploring the concept of water density. So density means how packed together molecules are and the mass of molecules. So hollow items have less mass than non-hollow items, and they are more dense. So water has a certain, their molecules are packed together in a certain way, so it has a set density. So if items are less dense than water, they will float. That means that the items are packed together less closely, so they're less dense, and they will float on water. And if items are more dense, they will sink in water. So that means that the molecules are packed more closely than water, and they are heavier. So lighter items float, heavier items sink. So this is a really good time to put our scientist hat on and think about different objects' densities, and we can predict whether they will float or sink. So let's get out our materials here. And what should we start with? Let's start with the pencil. So I have just an unsharpened regular pencil. I'm gonna drop it in and let's guess if it floats or sinks. Looks like it is floating. You can see that in there. All right. So our pencil floats. That means that the pencil is less dense than the water, and therefore it's floating. I should also mention that it's helpful to have some paper towels set aside, and I do out of frame here, for you to put your wet objects on after they come out of the tank, just to keep everything dry. Okay, what should we do next? Let's do the votive candle. Okay, this is just a small candle with a little wick that I haven't used yet. Okay, do we think it's gonna float or sink? Looks like it's floating. There we are. Okay, so the candle is floating. That means that it is less dense than water. So the candle's molecules are packed less densely, less closely than water, and therefore it floats. All right, let's do our school erasers, just basic erasers. I'm gonna do these two at a time here. What do we think, float or sink? And they sunk straight to the bottom. You see that? Yeah, so they are more tightly packed together. All right. Some paper towels here to keep my hands dry. Let's do our little pencil topper erasers. 4 of these. So I have a blue, orange, yellow, and pink. I'm gonna drop all these together at once. Now, these are interesting because they have a little hollow on the inside. So I mentioned in the beginning that hollow objects don't have as much of a density as solid objects. So if we look at our school eraser, this is all the way solid. So I think that the school eraser, obviously it's a bigger size as well, is much more dense than these pencil topper erasers that have a hollow middle. So knowing that, do we think that the pencil topper erasers will sink or float? What do we think? Let's give it a try. Ready? And they have sunk all the way to the bottom. All the way to the bottom there. Completely sunk. Now, I hadn't tried those yet, but I thought that they would probably float, but I was wrong. All right. What's next? Let's try some pennies. So I have 5 pennies. And pennies are pretty lightweight, but they are pretty solid. So let's see, do we think that they are gonna float or sink? Straight to the bottom. They are sunken quite well. So those are heavier than water. You can try it with other coins as well, since different coins have different weights and different densities. Okay. Let's try some raisins. I'm gonna get a few out here. Okay, so I have a few raisins. And what do we think? And they sunk straight to the bottom. Okay, so the raisins sunk. The raisins are heavier. What about our green split peas? Let's try a few. Put just a few in. It looks like they are sinking. They've sunken straight to the bottom. So it looks like so far, most of our household objects have sunk, which means they are heavier than water. So I wonder if I have anything that will float. Trying to get all these little split peas out here. Bigger beans would come in handy, but I didn't have any in my house, so I had to use what I had. All right. I'm gonna call that good. Okay. Let's do some of our edible items here. So, I have 3 red grapes. Let's see. They have sunk into the bottom kind of slowly. Okay, so those sunk. Let's do our eggs. So this is just a raw egg. And what do we think? Sink or float? That's sunk straight to the bottom. And you want to be a little bit careful dropping it. Since it's a raw egg, it could crack and spill everywhere. So, and then this is a hard-boiled egg that I've labeled with an H. And is it gonna sink or float? So this is just an egg that's been cooked, hard-boiled, and it also sinks. So they are both sunken to the bottom. So cooking an egg did not affect whether it would sink or float in our simple float tank. Okay, here's my mandarin. And what do we think? Sink or float? Oh, did we see that? I'll do that one more time. So it is floating. Finally. Can we all see that? Finally, something's floating. So when I drop it in, initially it starts to sink and then it comes back up and starts to float. So we have found an item that is less dense than water and it's floating. So that means that in a mandarin, the molecules are less closely packed together than they are in water, and therefore it floats. So that's pretty cool. You can kind of push it down and it'll come back up. All right, let's do one last item. Let's do our Easter egg. So this is just a plastic Easter egg and I don't have anything inside of it. So it is hollow in the middle, right? When I snap together, there's nothing inside of it. It's hollow in the middle, there's nothing inside. So this is going to be a lot less dense than if I had a rock or something that was all the way solid. So what do we think? Do we think this is going to float or sink? Let's find out. And it floats. And it's floating on the top of the water pretty much. Which means that it is a lot less dense than the water. Like I have to apply a lot of force to push it down. And it actually has holes, so when I did that, I did fill up with some water. And that makes it a little heavier. And I wonder if I hold it down, will it sink? A little bit. I think I'd have to fill it up quite a lot for it to be heavier. So as you can see, it's floating on the top of the water there. And And that makes sense to me because these are pretty lightweight. It's just kind of a thin plastic, pretty lightweight. All right, so that was a look at our float tank, whether objects will sink or float in cold tap water. You can use lots of different items found around your house, tennis balls, play balls, rocks, anything like that. Really almost anything would be fun to just give a try. See if it floats or sinks. It's a good opportunity to talk about how objects are made of molecules and how the density of objects affects whether they will float or sink in water with water density. And it's just a fun scientific experiment to try a bunch of things around the house and see whether they float or sink. This next activity is a really fun way to make raisins swim around. So as we saw in our float tank, raisins, when placed in our float tank, just sunk straight to the bottom. That means that they are more dense than water and they will always sink. But what if I told you that there's a way to make them float and dance around, swim around? And this is how you do it. So our materials are pretty simple for this one. We have some raisins, have a clear glass. You can use like a mason jar if you want as well. And then I have clear carbonated soda. So this is what I had on hand. You can use really any type of carbonated liquid, so sparkling water, a different type of soda. Clear color is best because then you can see the raisins really well. It's very important that it has to be carbonated. So I'm going to pour my carbonated soda. And you want to make sure that it's not too flat if you can as well. So this one is a little tiny bit flat, but let's see if this still works. So I'm just going to pour my soda into the glass. Do about 2/3 full. Okay. Let me see. All right, and then I'm gonna take some raisins and I'm gonna drop them in and we're gonna see what happens. So they are sinking. Okay, they are sinking straight to the bottom. What happened? Oh, there it goes back down. Go back up. Tapping on this kind of helps release some of the gas as well. There it goes. So what's happening is the raisin itself is more dense than water, so it will sink. But when you add carbonation, which is carbon dioxide, when you add carbonation, the little bubbles that you see float basically because they are less dense than water. So the carbon dioxide is less dense than water. The raisins have lots of little crevices that are catching the carbon dioxide and causing the raisins to swim up. So basically the carbon dioxide gases are getting stuck in the raisins and making them float up, swim around. So this is kind of fun. Try it with different types. You try it with different types of carbonation, so different types of soda versus carbonated water. And you can also try this with cooked pasta noodles. So like angel hair spaghetti, you could try it with that. But using raisins I think is pretty fun. You can sit and watch it. I think my soda is a little tiny bit flat because it's a little bit old. So if you have a new soda that you can use, it probably would work better because the longer soda sits, the more flat it gets, which means the carbon dioxide kind of goes away. but we can still see it happening just a little bit. In our last activity, I'm going to be making a shaving cream cloud that will actually rain. So this is a fun way to simulate, kind of illustrate the way that rain falls from clouds. So I have just that clear glass that I filled almost to the top with cold tap water. You can use a mason jar. You want something that's clear so that you can see what's happening. I have some shaving cream, and I have some food coloring. You don't have to use food coloring. You can use plain water, but food coloring makes it a lot easier to see what's happening. So I'm going to take my shaving cream, give it a good shake. I'm gonna put it on top. I'll show you this way. Put it on top to make our cloud. So I'm just gonna go ahead and make fluffy little clouds here. All right, so that is our cloud. It kind of looks like whipped cream, but definitely don't want to eat this. All right, so let's see if I can adjust the camera here. Okay. All right, so this is our cloud. And I'm going to take the neon blue food coloring here, and I am going to start dropping it into the cloud to simulate kind of water. So what's going to happen is I'm going to drop the food coloring. Show you here. It's going to sink through the shaving cream, and it's starting to make our cloud heavy. So this is what happens. The moisture goes into the cloud, starts making it very heavy, and eventually it will become so dense that our rain will start falling from our cloud and into our liquid. Like you can see here, it started to fall. So it's becoming, the cloud itself is becoming too dense, more dense than water, so it's starting to sink. So there's our rain cloud. So this is a fun experiment to do. Helps really illustrate how rain starts to fall from clouds. Keep watching our Tacoma Public Library YouTube page for more virtual programming. Bye, everybody.